Hello students, today we are going to study next point, use of multiplexers in a combinational logic design. Multiplexers ICs for 2:1, 4:1, 8:1, 16:1 multiplexer are available. We can use them to implement given Boolean expression representing the combinational circuit. Thus, it is possible to design and implement many combinational circuits by using multiplexer and few gates. And the advantages of multiplexers for logic design are that is logic design is simple and that it is not necessary to design the expression, and by using that multiplexers that minimizes the number of ICs that required to be used. And that use of multiplexer for combinational circuit design, first truth table or logic expression and standard SOP and POS form is given to us, and we have to design the procedure given below to use the mux for implementing the given logical expression. From the truth table or SOP or POS expression is given, or max term and mini-term are given, and from that we implement the logic expression using a multiplexer. First, that expression is given, and that expression, from that expression you have to find out the min term or max term. If truth table is given, from that truth table you have to design the multiplexer or implement the logic diagram for multiplexer. For that one truth table is given, that example for designing the combinational logic. From the truth table, how to design the multiplexer. That truth table A, B, C and Y output 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. This is the one truth table, and for that truth table there is the Y output is given as a logic as it is given 1 0 1 0. This is the one truth table is given, and from that truth table we design the multiplexer. For this multiplexer or for this truth table, which multiplexer is required, and express the Y output in a standard SOP form. That this Y output as expressed as in a standard SOP form. So that Y is equal to summation M. This is a summation M is indicating as a SOP expression. So from this truth table, where is the output 1? For that output 1 input is considered. From that input, here is Y output 1, so this input line 0 0 1, so that min term is 1. Next, here is output 1, so that for that input min term is 3, and here is 1, that number is 1, here output is 1, that input line 1 0 0 as a 4. Next, output as a Y 1 here, that input line 1 1 0 means 6, so mini terms are 1 3 4 6, output is 1. This is the expression, this is the SOP standard SOP form, and that connect the data input lines, these data input line, this input and this is the output. From these data input lines, that 1 3 4 6 is connect to logic 1 and remaining connect to logic 0, and from this expression or this SOP or mini term you have to decide which multiplexer is required. That values are from 0 to 7. So values are from 0 to 7. So we require the 8:1 multiplexer. So this is the 8:2. Use of multiplexer in combinational logic design, and that in that combinational truth table or logic expression in a standard SOP or POS form given to us, and from that we have to implement the multiplexer. That is the procedure. So 8:1 multiplexer required. 8:1 multiplexer data input line are required 0 to D0 to D7, 0 1 2 3 4 5 6 and 7. These are the input lines. 8:1 multiplexer. One output line, and how many a single 8:1 multiplexer required? The select line S0 S1 S2. These are the select line, and from these select lines, from this truth table, this is the Y output. There are 0 to 7 data inputs, and 0 to 7 data inputs, there are the three inputs A, B, C. This A, B, C inputs as a consider connect at the inputs to the select lines of S0, S2, S1. So this is the A, B, C input. A, B, C input from the truth table. And from this truth table, there are many terms 1, 3, 4, 6. These are connected to logic. These are connected to logic 1, and remaining lines are connecting as a logic 0. That's 7, 5, 2. These lines are connected to logic 0. This is the we design the multiplexer in a combinational logic diagram. Truth table is given. Truth table is given. If there is a implement the function that expression is given, summation m, minterms are given 1, 3, 4, 6, and here using 4:1 multiplexer is for this logic function there is a f of a comma b comma c. F of a comma b comma c is equal to summation m 1, 3, 4, 6. Next problem, there is a next problem, second problem, y is equal to summation m 0, 3, 5, 6, 7, 10, 13. These are the values. That summation m is a SOP expression. For these values, which multiplexer is required, first we decide. From that values are from 0 to 16. So we require the 16:1 multiplexer. 16:1 multiplexer, we have to design the combinational logic circuit by using the multiplexer. And summation m, that is value 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the data inputs for 16:1 multiplexer. 1 Y output, and there are required for 4:1 multiplexer S0, S1, S2, S3, 3 select lines, and here only values are given. Y is equal to summation m 0, 3, 4. If there is a f of function of a, b, c, d, then that S0, S1, S2, S3 is a function of a, b, c, d. We have to write here. Then that value 0, that 0 value 0, 3, 5, 6, 7, 10 and 13 we connect for logic 1, and remaining lines we connect for logic 0. That values 0, 3, 5, 6 are connected for logic 1 and remaining connecting for the logic 0. This is we design the 16:1 multiplexer by using the combinational logic circuit. In first problem there is truth table given, to design the multiplexer. In this problem the values are given, and from that values you have to design the multiplexer. Next problem, that third, f of a comma b comma c is equal to pi m 0, 1, 0, 1, 3, 5, 7. Pi m means that expression is in a POS form, that pi m is connecting the POS. In this max term are given, so you have to connect the corresponding D inputs, that is the D0, D1, D3 at connecting to logic 0, and remaining lines are connected to logic 1. This is the only change in that in a SOP or POS, or in a minterm or max term. In a minterm, that minterm values are connected to logic 1, and in this that max term are connected. These are the max term, that pi m is indicating as a max term, that max terms are connected to logic 0. So values are from 0 to 7, so we require the 8:1 mux. 8:1 mux. 8:1 mux require 3 select line S0, S1, S2. This is the function of A, B, C. So here we write the function of A, B, C. In here directly the given that is not a function of any input, so we only write the select lines S0, S1, S2, S3. But here is the function in this problem f is function of a comma b comma c. So for S0, S1, S2 a test 1 multiplexer required 3 select line as a input line A, B, C, D. Y, 1 output, and inputs are 0, 1, 2, 3, 4, 5, 6 and 7. These are the input lines for the a test 1. And these a test 1 multiplexer in this POS expression, that is the max term is given. In that max term, that 0, 1, 3, 5 and 7. S0, S1, S2 is the select lines, that is the function of a comma b comma c, and that pi m, that pi S0, S1, S2 is the select lines, that is the function of a comma b comma c, and that pi m, that pi